Hi everyone, today what we're going to do is do the area between two curves, and we have a couple characteristics and a couple things we need to use our calculator for. You can use Desmos, of course, to do this, and it would be faster, of course. But if we're taking the AP exam, you need to do this on your graphing calculator because that's the tool you're allowed to use. And in an in-person test, you won't be able to use Desmos, even though it would be faster to type it, right? 100%, copy and paste. But if we're working in the constraint of the AP exam, then we want to use the calculator. So our first problem is, so the title is area between there's two e's in between, two curves. Okay, now two curves, we're talking about some upper and then lower bound. So we have some f of x and some g of x. Now the problem here is we don't know what your a value is and we don't know what your b value is. But they do still exist, and we have to find them. And there are points of intersection. And if you remember before on the TI calculators and even on the Casios, you can find where they intersect. And there's a way to calculate that. So we're going to be using that tool to figure out what our A and B value. But so far, to set this problem up, it's just pretty much A, B, and we're doing upper minus lower. F of x minus g of x. Okay? And we're going to multiply that by some dx. Now again, this basic idea is just the sum of small little rectangular areas. What I mean is, if I go f minus g, that'll give us some height difference. Now if I say this is 5 and this is 2, the height difference is, let's say, 3 here, right? If we multiply the 3 by a little bit of dx, it would give us a small rectangular sliver, pretty much the size of a fine hair, let's say. And if I do this enough times from A to B, we would have added up all our area, leading us to the full area. Okay, so that is pretty much the idea. It's almost like a physical thing. This is our height, and this is our base. I want you guys to realize that that's our height and our base. And the s, the integral, is just like a big S for adding. So here's our first example today. We're going to say y is equal to 2 squared of x, and y is equal to x squared over 4. And these are our two equations. Okay, there are two equations. You might know what these graphs look like. One is a parabola, and one is a square root graph, which looks like half of a sideways parabola, right? Half of a sideways parabola. By their powers combined, let's go ahead and look this up. I'm going to go ahead and share my second screen here. Gosh.
Mister, these questions won't be given to us on the test without in the non-calculator portion, right?
Um, they can be if it's an easy type question, like you can find where they intersect. But if it's hard to find out where they intersect, if the intersection point is not easy to find, then of course no. But if they do give you one, they might give you, for instance, a parabola and a line, which is easy to find. That's a lot easier to find. Okay, it's easier to solve for these. So let's use this one real quick. So let me go and share my other screen on my calculator. Here we go, sharing second screen. Oh, hey, hi there. That's scary. So come on, go second screen, go. Yeah, I just stuck on the face of me. What in the world? Come on, buddy. Come on, buddy. It's back to me. Hi. Share screen. Oh, share. We're sharing my screen, not my camera. Oh, I put camera. Now everyone knows that I listen to audiobooks and what my daughter looks like. Go YouTube. All right, so I'm gonna hit y is equal to, and let's go ahead and plug in your equations we talked about before. Darn it, it's gonna be 2 square root of x and the square root is above the x squared, and x is the variable. Okay, that's my button for x. And then I'm going to go, my second equation is x squared over 4. Okay, x squared over 4. Let's go ahead and graph that. As you can tell, my graph doesn't make any sense because my my frame, I guess, is wrong, right? So I'm going to change my zoom. I'm going to zoom, and I see Z standard number 6 to fix it really quick. Z6 allows you to reset your zoom. Okay, I see where they intersect. Now the problem is I need to figure out what they intersect. So we can use second calc to find out the intersection point. You see the word intersect, hit 5. Now it's always the same question. Pick Y1, pick Y2. So all I'm going to do is quickly hit enter, enter. Enter for Y1. If you look at the upper left hand corner, now it says Y2. Enter again. Now that's Y. I hit enter, didn't I? Oh,
But Mr. Ko, where do we
yes.
go?
Do it on a case load.
Casio, I need to figure that out. But take a look if there's any instruments in which you can find. Do a quick Google search for it real quick.
Jessica, you can press after you graph, you can press F5 where it says intersect, and then you can find the intersects.
Good job.
Mr. Ko, how do
Okay,
you do
found
the
it, thank
on
you.
the TI-84?
Same thing. So you're still going to graph it, and then you should be able to second calc. Calc is right above the word trace. And then you want to hit intersect, 5. So they should be the same keys, I think. And then they always ask you the same 2 questions. First curve, second curve. So you just hit enter, enter if they're Y1 and Y2. And then they're going to have you make a guess. Why do they make you have a guess? You're like, well, I'm asking the calculator to give me the answer, not for me to guess. And as you can tell here, there's actually 2 intersection points. And it doesn't know if you're talking about the first one or the second one. That's why they want you to guess. So my first guess is going to be 0, 0. Great, we have 0, 0 as my first intersection point. And my second intersection point is, let's go ahead and find it again. We're going to hit math 5 again, or second calc, hit 5. And then I'm going to hit enter, enter fast. And then I'm going to run my mouse, my little ticker a little closer. It doesn't have to be perfect. Doesn't have to be perfect. If I hit enter, you can see it got close to it. And the intersection point there is 4, 4. Perfect. Okay, now that we know where they intersect, we can go back and rewrite this whole equation. So the cool thing is, remember, we already wrote the equation y1 and y2, right? Take a look here, we already wrote y1 and y2. So I don't want to rewrite it in a calculator because it takes so much time, especially if this was just a super long equation. So second quit, let me go and clear this so you guys don't have other stuff. I'm going to have math 9 for integral. We have our a to b. We said it's going to be 0 to 4. These are the x values from 0 to 4. Our equation is upper minus lower. Now, if you forget which one's the upper and the lower, let's go back to the graph. And I want you guys to hit the word trace. If you hit the word trace, you can see that it is following the line of the graph. But which graph is it following? On the upper left-hand corner, you see it says y1. y1 is the top graph. If I hit down, it'll skip to y2, which is the bottom graph. When you hit up and down, it'll cycle through all the graphs that you have listed in your y equals 2. So up and down helps you cycle through all the graphs. So if I hit up and down, or down, 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 it'll cycle between all the graphs I have graphed. And you can tell which is the upper and the lower. So the upper here is going to be my y1, and my lower is y2. Now let me go back and share my screen up back here.
Your x's are 0 and 4. So would you put the one that's less?
Yes,
on
always lower to
bottom?
higher. So 0 to 4.
Okay.
And then we're saying upper minus lower. So that's, in this case, sorry, it's upper minus lower. So we said the upper was our square root, our y1, and our y2. So y1 minus y2. Of course, if you're writing this on the AP exam, they would actually let you write y1 and y2 as long as you define which function is which. So if I wrote it this way, be advised, this is okay. That's 100% okay if you're lazy about writing the equations, because you've already said, hey, y1 is this and y2 is this. They'll actually let you do that. Okay. Now I'm going to go back to the calculator to show you guys how I did that.
Mr. Ko, when doing the like finding the last point, I got like 4.04.
4.04.
Like I got really
Did you
close to
use,
4.
did you intersect or did you trace?
I might have done intersect.
Make sure it's intersect. Check one more time and make sure you did write the equations correctly. If you did intersect, it should be really a lot closer than hundreds place.
Okay.
Sometimes they'll do 4.00000000 like 1 or something like that, and that just means 4. But I feel like yours
Okay.
is a little bit more off.
And
So
I
go
might
ahead
have
and,
clicked. I might have clicked the wrong trace. Like you said, click it twice or whatever. I might have.
so go hit
I
second
don't know.
calc again, and let me follow you. If you hit
Okay.
intersect, and then you look at the question. The question says first curve. So the first curve I'm going to choose is y1. And if you look at upper left hand corner, that's the y1. Yes, I want to use y1. And yes, I want to use y2. And then make a guess. I'll make a guess over here. And it should say 4 point, really close to 4.0. If you just hit trace by itself, that's what I'm seeing 4.4 because you hit trace and not intersect.
I have 4.4 now, but I still don't know what I did.
I think you just hit trace. If you look here, I have 4.4 also, right? Like what you have.
Yeah.
But it's because I just hit trace. And this is me just running around the graph.
Oh, but then you have to do. You have
have
to
to
click
hit-
enter twice, right?
You had to, yeah. So I had to second calculate and then find that intersection point. And then first curve, second curve, I had to hit it twice. And then do you see how it says guess?
Mm-hmm.
So read the instructions and then guess says, now it'll guess for me. Or I mean, it's me guessing for them to find the actual. And again, the
Okay.
reason why they make you guess. So what if you have 3 intersection points? So it's actually smart of the programmers to let you pick which one you want. Okay, so to do this in the calculator again, since we wrote the y1 and y2, remember second, sorry, it's not second, it's vars, hit vars, y vars, function. And we're doing y1 minus y2. So don't make this mistake. If you put y1 minus y2 or y2 minus y1, it'll give you the wrong answer. Y vars. And once you get pretty fluent with this, it becomes really fast.
Where'd you do? How'd you do it again? Sorry.
So you hit vars, the word letter is vars, vars,
All right, got it.
and then y vars because it's a y variable. And you have to tell it what type of equation is it, and we're looking at basic functions here. We're not looking at parametric or polar. And then
All
you
right, I
pick which
got
one you
it.
want. And make sure you do pick y1, y2 the way you wrote it. Which one is y1, y2, and that does matter. Okay, I'm gonna hit enter now, and we should end up with a nice answer, tick tock, tick tock. And I got 5.33. Okay. Now on the homework, please be advised that not all the questions are going to ask you to solve it. For the homework, some of these questions are just set it up. Please set it up. Okay. Some will solve it, but for the most part, a lot of them are just set it up. And I want to make sure you guys are able to find those intersection points. Remember, this is just multiple choice, so for you guys to just practice it. Okay. So make sure you guys are going through the motions, not just saying, oh, hey, look, this must be the answer. Okay. Some of the answers are on here are not multiple choice. They're just filling in because I want you guys to plug into the calculator and give me the answer. I would say it's probably safer to write the fraction version if possible. If not, I guess the decimal's fine. It should take it. Okay, there's no fancy way for me to write this on as a fraction on this calculator. Okay, and that's our answer. Okay, let's do another problem that looks even more crazy. Okay, let's look at another problem that even looks a little more crazy. Okay, let me switch screens. Okay, were you guys all able to get 5.33? Actually, I should check right now. Were you guys able to get 5.33? If you're able to get 5.33, go ahead and click yes or some type of positive affirmation in your participants window. Click participants and then some type of positive affirmation. Okay, I got 2 people, 3, 4, Just to make sure like we're all kind of on the same page, not just Mr. Ko here. Sometimes it's just in the more, right? Just give me a thumbs up. Okay.
So wait, Mr. Ko, when you put in the equation on top, what was that giving you again?
This equation that you see on the screen currently.
Yeah, the y1
Okay,
minus y2.
So if you look at my y is equal to, it's actually copying these equations for me, so I don't have to rewrite them.
Yeah.
So it's copying the 2 squared of x and the x squared over 4. So it saves me time.
Okay.
Okay.
And the answer it gives you, what does that like
That's
relate
the solution to the integral, which for us, it's the area between the two curves.
to? Oh, thank you.
Right? Because it's adding the cumulative change. It's adding up all the small parts for us, so we don't have to do the work. Okay, so let's do another problem here. Now, the next problem is going, oh, come on, take over. Oh, I don't know why. Okay, so let's do another problem. And the next problem is, we'll try this again. I'll let you guys try this yourself. Y is equal to negative x squared over 2 plus 2x plus 1. And y is equal to negative x squared plus 6x minus 5. And we'll call this y1 and y2, so we can easily talk about that. Now go ahead and write this on your calculator. We'll see how that looks. We're taking the integral from some a to some b, and we're not even sure which one is on top yet. We don't know which one's on top. Because we don't know where they intersect, we don't know which one's on top. So let's go ahead and graph that. So everyone, please write these equations down on your paper. I'm going to switch screens so you guys can't see it anymore, unfortunately. I should do that picture in picture. I saw someone do a picture in picture once. Oops, wrong one. Who broke some monitors there? Okay, so I'm going to change my y1 and y2. If you want, you can practice using clear and delete. They're different tools of getting rid of stuff, but they're different. They're both useful. I'm going to use negative parentheses. No, I don't need parentheses here. X squared over 2 plus 2x plus 1. That's my first equation. Second equation is negative x squared plus 6x minus 5. Okay, there are Apple apps that do something similar to this, but it's not the same. So it's something we have to try to figure out. And you don't get fast at this unless if you're practicing it. So if you guys can't find a graphing calculator, again, ask a friend that's taking calculus, or if you know someone in college, maybe they have a graphing calculator sitting around. Find an aunt. Okay, so you can see that they're overlapping. One is on top sometimes, one is on top some other times, right? So they're kind of taking turns, and we can kind of see where they're intersecting. If you want a better view of this, we could hit zoom and do a zoom box if you want. But this again is burning time. On the AP exam, we don't have that much time. But if I want to, let's go ahead and do a zoom box here. Zoom box, the box, zoom box. See how long it takes for me to do a zoom box? Okay, zoom box will allow me to zoom in. And then I'll have to regraph it. Okay, we can see where they intersect. Now, I could try just walking my pointer to it. I mean, that's one thing you could do. You could hit trace if you want. But you can see these stupid calculators never give you the numbers you want. See, I can never get to 0 I get close to 0, like 2, but I can't really get to 2. It's because that's just the way it's calculated. It doesn't know that you're looking for that whole number. It's just picking a point that it can graph. I think it's probably related to the pixels, maybe. Actually, I don't know. All right, so instead I'm going to go ahead to second calc. I'm going to calculate the intersection point. Hit 5. Enter, enter, because first line, second line. And then I'm going to make a guess. Just get close. Don't have to get too close. And that will give me my first point is at x2. X is 2. Y is 3. I don't need that y value. Second calc again. I'm going to find the second intersection point. First curve, second curve. And then you'll walk over there. Get over there. Close enough, close enough, close enough. And then our second value is 6. So we're going from 2 to 6. Now, next thing I want to make sure I know which function's on top. So if I go back here, I see y1 is on bottom. Oh man, y1 is on bottom. And y2 is on top. Okay, y2 is on top and y2 and y1. And then second quit. So y2 and y1. So we're going to do math 9 again. Math 9 from 2 to 6 because those were our intersection points. And we're going to use y vars. And this time we're going to subtract 2 from 1. 2 minus, whoops, two minus 1. And then I want to show you guys a trick after this. Okay, 5.33. Oh my gosh, it's like almost the same answer. Okay, so what if I had flipped the values around? What if I flipped the values around? What if I accidentally mixed them up? And I wrote instead, insert y1 minus y2. You would notice that the only difference, it would have been negative, right? It would have been negative. And let's talk about that for a moment and try to find a way to fix this so we don't have to worry about which order anymore. Now, I only teach this after I teach the order. So let's go back and take a look over here at my tablet. Share screen. So we said it was y2 minus y1, and that gave us negative, positive 5.33, I think. 5.33. And if I had mixed it up, if I went the wrong order, if I said the integral from 2 to 6 of y1 minus y2 dx, this gave us negative 5.33. Now, why is that? Why is it that when I flip the order, it gave us a negative? I want to show you guys the graph really quick one more time. The graph looks something like, darn, I should have made the meat a little better. Something like that, okay? Make it up. 6 and 2. I know it's a little off, but sure. So my example is, I'm going to give you guys some easy numbers to look at. If this was 6 and this was 5. If I say 6 minus 5, 6 minus 5 is positive 1. Right? Obvious, right? 6 minus 5, y minus y. But if I spin that around and say 5 minus 6 instead, this will be negative 1. It's the same value, but it would just have been a negative because we went in the wrong order. Right. Now on the AP exam, if this was a free response question and they wanted you to set it up and you set it up incorrectly, of course they're going to minus points for it because you set it up incorrectly. So it's important that you set it up in the right order. But there is a way of fixing this. My question for you, if I find the area between two curves, upper minus lower, upper minus lower, upper minus lower, upper minus lower, wouldn't it always be a big number minus a small number? So smaller number. So that would always yield you a positive value. So how can I force negative numbers to become positive with an absolute value? We could rewrite this equation here with an absolute value sign instead. And that would like totally work. If I throw an absolute value sign here, or here, or any of these, that would actually fix our problem. And that is a cheat to fix the order. If I don't know what the order is, I can just throw an absolute value sign to fix it. But this isn't always an answer. Okay? So if you get the order wrong, you're kind of screwed. But if this is just a calculator problem, you can always use the absolute value sign, and it does fix that negative to become a positive. Okay, so if you want, you could write integral from a to b of absolute value of f minus g dx. And that would totally work. And let's try that right now in our calculator, if that's even possible. Let's see if we can figure out how to do that. I'm going to share my screen again. Oh, cancel. Hey, daughter of mine. So I'm going to go back here, hit enter. I'm just going to copy it. Hit enter. Now, the calculator is written in such a way that you just got to get used to how it operates. And one thing is, like, it doesn't allow you to enter values easily, because if I press something, it's going to actually delete it. So if you look on top, there's an INS button. Oops, there's an INS button. And I'm going to use second insert to insert something. So I'm going to take this here. I'm going to go in the front where I want to insert it. I'm going to insert, second insert. I want to insert an absolute value. And where's absolute value? I find absolute value in math. Math, is it, I think in number, ABS. Do you see I see ABS here? That stands for absolute value. ABS. And they're actually going to make me rewrite it. Oh my goodness. We're going to do vars, y vars function, y1 minus vars, y vars, y2. Okay, so I'm going to pause here, and you can see now I wrote an absolute value into my problem. Okay, I wrote the absolute value in there. How did I find the absolute value? That absolute value was in math, numerical, num, right? And the first one, ABS, is not about my abs. Okay, it's about absolute value. If I hit this, this will give us our positive answer. Okay, so let's move on here. And we have one more scenario, is what if they double cross you? What if they double cross you? So let me go ahead and share. And if this worked a lot better. Okay, here we go. So our next problem is going to be this one. Let's try to do the easy one. X cubed plus x squared minus 4x, that's my y, we'll call it y1, and y2 equals to 2x. So make sure you write that down on your paper, please. And then once you're done copying, go ahead and start copying this onto your calculator as y1 and y2. One reason why we don't do the absolute values as often is because you can't, it becomes very difficult to, a lot of work to do absolute value, integrals of absolute values. The integrals of absolute values take a lot of work to do. But on a calculator, it doesn't take that much work at all. Okay, I'm going to go ahead and share my screen once again for my calculator. Okay, y is equal to, we're going to have to rewrite these equations. X cubed, x caret 3. Clear it. So the caret is the little up arrow, and that allows you to do exponents. X caret 3, take a look at that. Hit to the right to get out of the exponents, plus x squared minus 4x. Okay, that's my first equation. My second equation is just simply 2x. Okay, you can also again do this on Desmos. That's a nice thing if you want to use that to quickly graph it, but that's not going to help you solve it. Okay, Desmos is not going to help you solve it. Okay, second quit. I'm going to go ahead and graph it. Now, again, if you look at my screen, it is not in the right setting, right? Man, I gotta zoom out. So it's zoom standard Z6. Standardize my zoom again. And I am seeing that, oh my goodness, it is intersecting in 2 different places. Okay, it's intersecting in 2 different places. So.
Isn't it 3 because of the
Okay, thank you.
0?
I meant 2 different areas I have to worry about. But you're right. There are 3 different intersection points. I just used the wrong term. My brain's stupid. Okay. So I'm going to go ahead and switch back again. Oh gosh, switching back and switching forward. Okay, so I copied my dumb version of this. Now, we need to figure out which one is y1 and y2. Of course, this is going to be our y1. This is our y2. Okay. So between our first intersection and second intersection, and then the intersection points, we have to realize that the y1 is on top and the y2 is on bottom. Then at the next intersection point, we flip. y2 is on top now and y1 is on bottom. So the way we simplify this, just like in geometry, we try to make things a lot easier, is we break this up into 2 different parts. We have the area of my first region added to the area of my second region. So we do the integral from a to b of y1 minus y2 dx. And then we're going to add from, call it b to c, a, b, and c here, right? Of y2 minus y1 dx. Okay, so take a look at what I did here. I broke up this huge problem into 2 separate problems. Instead of running the whole one equation through the whole graph, we just said, hey, we'll do our first meal of the day, take a break, and then take our second meal of the day. Now, why do we have to split it again? It's because if we look at this form, it says y1 minus y2. Sure, it's y1 minus y2 for this first part. But once I get to the second part, it's not y1 minus y2 anymore. It goes y2 minus y1. And that wouldn't be reflected in our integral. Now, if you look at your homework today, a couple of questions will just be a step. I'll even give you the graph. I'll give you a picture of the graph. All you have to do is pick the correct setup. All right, so let's go ahead and find those intersection points now. Let's go back to the calculator. So I'm going to actually set this up so you guys can kind of follow along a little better. So share screen. Okay, so I know the setup's going to be Math 9 twice plus Math 9. Okay, you guys see I have 2 integrals. We know the first one. We don't know anything about the first one. We don't know anything about the second one. So let's go ahead and take a look at the graph again. So which one is which? Which one is upper, which one is lower? I'm going to pick the trace. If I do the trace, we see that in my first region, you guys can see the little glowing star, my y1 is on top. Okay, if my y1 is on top, in my second region, y1 is now on bottom. And hopefully you guys can see that. Second quit, I'm going to write as vars value function y1 minus vars yvars function y2. And the second part here, we're going to go ahead and write that down as vars y2 minus yvars y1. All right, so we set that part up. Now, only thing I need is my a and b values, figure out where they intersect. Go back to the graph. Okay, the intersect where? So we're going to go second calc. Find the intersection point. Just you can skip it and just hit 5. Please just hit 5. Don't go down, 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 down. Don't do that. Just hit 5. And then first curve, second curve is those dot dot. Hit it twice. And then let's go from left to right. First guess is at, take a look here. I need the x value, not the y value. First value is -3. I'm going to write this for you guys. This is going to be -3. Slowly filling this in. Okay, let's find our second intersection. Hit 5. Enter, enter automatically. We're going to get to the second intersection point. Now, you can imagine if you guys don't have practice with it, this would take forever to do. Second intersection point is 0, 0. See, it even tells me intersect 0, 0. I'm going to plug in 0, 0. Again, please do not go back and forth in the calculator plugging this in. Like, write it on your piece of paper and then come back later and fill it in. I'm just doing it right now to show you guys the process. And then I'm going to plug in 0 here because we left off from -3 to 0. Now our next integral is going to be from 0 to what? Second calc, hit 5, and then we're going to go ahead and hit enter, enter, and then we're going to make a guess. Just get close, just get close. And that's going to tell me it's 2. And the answer is 21.08. Now, what if I did not switch? What if I said, know what? I didn't know that they intersect. And I would have wrote something like this. I would just wrote this from 2 to 2. If I wrote this, we'll see that the answer is not going to be as big as 21. It's going to be 10. Why? Because the first region would have been positive, but the second region, because it was flipped, would have been negative, and they would have canceled each other out. Okay. Now we also have a trick up my sleeves, and the trick up my sleeves is, what if I wrote this guy here, but with an absolute value sign, which forces all the values to be positive. Okay. Now take a look here. It's going to be pretty trippy. Here we go. I'm going to math new number absolute value. Okay. And then I'm going to stick the y1 and y2 inside the absolute value sign. y1 minus vars function y2. This is the lazy man's way, and you will see it will work. Come on. Come on. Waiting for it. Yeah! See, so it still gives us 21, and the reason why is, instead of us trying to figure out which one is on top and on bottom, it says upper minus lower regardless, and I want all those values positive. Okay, and that is actually the trick. If you have an intersection point someplace in between, and this is, let's say, the calculator portion, and you don't have to show work, because it's multiple choice, bam, absolute value always helps you get the right answer. Actually, even in the free response section, if you write absolute values, they will take it. This is a legit way of doing it. The problem is, it doesn't show you the nuances of you having to flip it though, and you're separating it into 2 regions, which I think is like the learning behind it. This is kind of like the shortcut. Okay. But on the CUDA homework, you will have to separate it into 2 different versions. Now, some of the problems here are, since I made a multiple choice, so you guys don't have to write this onto CUDA, okay? But when I'm looking for the answer 21, those will be right in. So you're just going to write that answer in.
How did you get the absolute value signs again?
It's math, number, ABS.
Oh, okay, thank you.
Okay, it's flexing on the calculator.
Wait,
Alright.
can you explain why you did the absolute value again?
Yes.
I was trying to figure out my calculator.
Let me go ahead and show you pictorially instead over here on my tablet. Okay, so what happens when you do absolute value is, first, let's take a look at what originally happened. We said y upper minus lower, right? That gave us some positive number. And when I flip it, this would give us a negative number. It's not that the value is wrong, it's just negative. So if I take the absolute value of that, it would still give us the difference. So when you do the absolute value of y1 minus y2, it gives you all positive differences. And the integral adds up those positive differences together. So instead of us breaking up into two separate equations, we can say, you know what, from a to c of y1 minus y2, I get it, you're going to flip. But when I say absolute value, it's going to be all positive values in between. These would all turn to be positive differences. So it just saves us time. And it's like the shortcut cheat way of doing it. Not that it's wrong, but if we didn't see why we had a split in the first place, it kind of defeats the purpose. So I think it's kind of cool. Okay. Now, the next part of this is us graphing the wrong way. Now, we've always said y is equal to, and when you see y is equal to graphs like x squared, these are regular function graphs that look like this. Okay. Now, what if I solve for x instead? If I said y is equal to x squared, solving for x, square root of y equals to plus and minus, so let's do it the other way. Plus and minus the square root of x squared. So x is equal to plus and minus square root of y. Okay, so we're going to graph in the wrong way. And in this case, this is a square root graph. And this would be a graph that goes, this would still be this graph, but in the twisted version. Okay? So these are exactly the same graphs. This graph here and this graph here are exactly the same graph. But I'm writing it with x equals 2 instead. Now, here's our issue. If I give you a graph that says x equals to y squared plus 8y plus 11, this is a positive parabola with zeros here are hard to find. But this graph would go this way actually. It would look like this. So it kind of is like our regular y is equal to, except it's spun around on the wrong axis. It's still a parabola, but it's a parabola in the y direction. And please realize this is up and this is down, because the positive numbers are over here and negative. Now, if I bound this by x equals to -1, let me graph that actually using a different color so you guys can see it. Darn it, wrong color. X equals to -1. So -1 would be about here. You can see that the region is closed, and what we do is we go not up to down, but we go right to left. I'll tell you that these points meet at, I'm going to give you the point actually. This is going to be, the point is -1, comma -2, and -1, comma -6. These are the points where we meet. So how would we write the integral for this problem? So for problems on the side, we're still going to do integral from a to b. Instead of f of x, is going to be, let's say, f of y dy. Okay, we're a function based on y, because y is our variable. This is a b. Okay. Actually, you know what? I'm sorry. Let me make a mistake here. It's f of y, let's say f of y1 minus f of y, f2y dy. Okay, so very similar to what we did before, except what we're going to say right minus left. Okay, it's right minus left. Now, a couple things I want you guys to catch here. Since we use y, a and b are both y. both y. So look at the y values. The y values are going to be -2 and -6, right? -2, -6. Which one is the smaller y value, the less y value? So that's how you're going to determine it. It's going to go from -6 to -2. So what we're doing here, we're going to start drawing our lines. Oops, darn it. Instead of right to left, we're going to go down to up. So take a look. We're going to go down, lower to higher. So from -1 to -6 to -2. And what are we subtracting? We're subtracting right to left. So the equation on the right is -1 minus y squared plus 8y plus 11. Gives yourself a nice parentheses, and then dy. So this is right equation minus left equation. So how would you plug this into a calculator? You just plug it in, but instead of writing y's, you just switch it with the value x, because your x's are now your y's. So I would still write this as integral of -6 to 2, -1 minus, except I would write x squared plus 8x plus 11 dx. And that's it.